Hello everyone, this is Nick Tuzov. This presentation is a project report and, on the other hand, it can serve as a small tutorial for entry-level developers who want to learn about the efficient C++ design principles. You will also see how to combine the computational power of C++ with the flexible graphical user interface tools of XLVBA. First, let me give you a brief intro into the subject matter for my project, performance evaluation of trading strategies. Then I will demonstrate the application and talk at length about how it was developed, what design principles were applied, and why. In the space of performance evaluation tools, multi-factor models are considered classic. They have been used to evaluate the performance of mutual funds and hedge funds. For example, suppose that we have capital T, monthly returns from a mutual fund. In this formula, they are denoted by RT. The difference between RT and the monthly risk-free rate, RFT, is called excess return. The excess return is represented as a sum of three terms. The part explained by certain risk factors, F1 and so on Fp, an error term epsilon, and the parameter alpha. In this example, alpha is measured in percent per month, and it is seen as a risk-adjusted performance measure. Since the very first one-factor model proposed in 1964, financial researchers have been very active in the quest for new risk factors. As a result, the Fama-French, Carhart, and Fan-C models were developed. The latter was developed specifically to accommodate the factors that are present in the hedge fund returns. The interpretation of risk factors is not always clear. For instance, the momentum factor was introduced in 1997, and as of 2004, there was no consensus as to whether it represents a new dimension of risk as opposed to a free lunch. Also, practitioners don't like that some factors have no direct link to tradable financial instruments. For example, the momentum factor is easy to construct on paper, but it's too expensive to create a tradable stock index that would have similar behavior. The standard multi-factor models award no credit for the market timing ability of the trader. Suppose the trader buys the market today and the market goes up tomorrow. The model will assume that it's the market that did the job, and the trader's alpha will be zero. In my opinion, the biggest problem with multi-factor models is that the risk-adjusted performance measure, alpha, is estimated with a very low precision. Suppose there is a large number of mutual funds that do have an economically significant outperformance, say alpha equal to 5% a year. Based on a typical multi-factor model, such as that of Carhart, only a small proportion of them will be recognized as outperforming. The multi-factor approach is so imprecise that it may take between 20 and 30 years of monthly data to achieve decent precision. To obtain the maximal accuracy, one should gather the information about every single trade. An example of a trade-based measure is given in this paper of Professor Aldridge. I like that paper because it gave me a clear idea for the general approach to trade-based performance evaluation, which I tried to implement in my application. The idea is that every moment when the trader has an opportunity to make an exercisable decision is informative. For instance, the trader may have no exposure at all, and this may turn out to be the only right strategy that deserves credit. Of course, we have to be reasonably sure that he monitored the market and made a conscious decision to stay out of it. If he did it because he was away on vacation, it's different. Next, let me demonstrate the application itself. The installation instructions are included in the distribution package. Upon installation, you will see a new tab in your Excel ribbon. Let's test drive the tool on the sample dataset that is supplied by the application. The input data consists of 3 columns: traded quantity, bid price, and ask price for the underlying asset. For instance, on April 1st, the trader bought 1 unit of the underlying asset. On April 5th, he did nothing, and on April 8th, he sold 4 units. If you want to specify a single price without bid and ask, you can make these 2 columns the same. Specifying input data is the first thing you do when you launch the application. You can select the input range either by mouse or by entering the address into this box. In theory, a worksheet in Excel 2007 can contain up to 1 million rows, and a pretty large dataset can be handled. A number of input data checks have been implemented. For instance, the input data range must not contain blanks or other non-numeric values. Here I select the header by mistake, and I get an error message. After a valid data range has been selected, you choose which test you want to run and specify the test parameters, if any. At this point, 3 tests have been implemented: sign test, correlation test, and runs test. I'm going to omit the test descriptions because they are provided in the help system. I will post this help file separately on the project page so that you can become familiar with the tests without having to install the application. Each selected test adds a results sheet to the end of the workbook that contains your input data set. If you already have run the tests, the old results will be overwritten unless the corresponding worksheets are renamed, hence this warning here. Now the application is calculating the test results. I slowed it down for the sake of demonstration so that you could see the animation in the progress indicator. In a real situation, it works much faster. And here we can see the test results. If you want to specify a new dataset and/or to run the tests again on the same dataset, simply retrace your steps in the wizard. That's it for demonstration. If you have information about some state-of-the-art trade-based performance evaluation measures, please let me know because I may wish to implement them too. For the rest of this presentation, I'm going to talk about the software development issues, so if you are not interested in C++, XLW, or Excel VBA, then thank you for watching.